by taking questions from this homework 4, which is what we talked about last time we was here. Oh, I was going to say Gabby, and I'm like, nope, that's wrong, Jocelyn. Apparently it was the right Jocelyn. 11. Number 11. Sure. Goodness. Lagsville here. Let's do this real quick. All right, number 11. So normally I would start by doing a prime factorization, but in this case, since I have in the numerator, both of these are 64, I would start just by multiplying those together. Furthermore, I noticed that when I go to add the exponents, the denominators are already matching, so I don't even need a common denominator. So that's pretty rad. That gets me to here. Now I'm going to go ahead and do my prime factorization. So 64 is 2 to the 6th. And 4 is 2 squared. So that gives me 2 to the 42 over 9. And this is 2 to the 3 over 2. So I reduced after I multiplied that, just FYI. Well, I guess I could have reduced this one too, huh? That's 14 over 3. And then since I have the same base for my exponent in the numerator and denominator, I can subtract those exponents. So I'll make a common denominator to do that subtraction. That common denominator would be 6. So far, so good. Okay, now that I have that down into a single thing, I'm going to rewrite that as a radical. So remember, the denominator tells you the index and the numerator tells you the exponent. But I noticed that 19 is bigger than 6, so I know I can reduce this a little bit. So if I break 2 to the 19 into packets of 6, I can get 3 packets of 6 out of that with 1 left over. So 6, 6, and 6 is 18, and then 1 more gives me my 19. So these guys tell me I can pull out 3 2s. And then this guy here is all that's left underneath. So I could call that 8 times the 6th root of 2. As my final answer. Feel okay there? Who else? Any other questions here from this sheet? Lils? Sure. Which one? Okay. So I'm going to start by doing prime factorizations. So far, so good? Okay. So I notice that here and here we can do some reducing. So this piece can reduce down to 2 cube root 2 squared. And this one down to 3 cube root 3 to the first. You agree with that? Okay. So what I'm going to do now is I'm going to rationalize my denominators. So I notice in the first fraction I have this square root of 2. And I notice in the second fraction I have this cube root of 3 to the first. Uh-oh. In the first fraction, I'm going to need one more 2. To get 3 cube roots of 2, right? Or I'm sorry, cube root of 2 to the third. And in the second fraction, I'm going to need 2 more 3's to get cube root 3 to the third. Does that feel okay?
Yeah.
Okay. So when I do that, I have 5 cube root 3 squared times 2 to the first over 2 times 2 minus 3, cube root 2 to the first times 3 squared over 3 times 3. Cool there. Now, 2 times 2 is just 4, 3 times 3 is just 9. To subtract these, I'm going to need to make a common denominator. The common denominator between 4 and 9 is 36. So the first fraction I'm going to multiply by 9 over 9. The second fraction I'll multiply by 4 over 4. Still doing okay? All right, so that's 45 cube root of 18, 3 squared times 2, minus 12 cube root 18, 2 times 3 squared, over 36. Since the cube root of 18 is identical, I can subtract these just by subtracting their coefficients. So 45 minus 12 is 33. And then 33 and 36 can reduce because there's a factor of 3 in common to both of them. And that would be my final answer. That was a rough one because you had to reduce the radicals, and you had to rationalize the denominators. Then you make a common denominator. Then you had to reduce your fraction again. That's kind of as bad as a problem like that with like denominators can get. There's a lot of stuff going on. Reese. Homework 4. Number 15, you say? Okay. So I'm going to do, as my first step, I'm going to do the prime factorization. And at the same time, I'm going to rewrite these as exponentials. Is that okay? So I have 2 squared times 3 to the 1/2. And then 2 to the third times 3 to the first to the 1/3 over 2 to the 4th times 3 to the 1/4. And then I have 2 to the 5th times 3 to the 1/5. I'm now going to use property 2 to get rid of these parentheses. So if I have an exponent of a product like that, the exponent's going to apply to both parts of the product. So far, so good, Reese? Now, for each one of these little guys, I have an exponent of an exponent. So in that case, I multiply. So 2 times 1/2 is 1. 1 times 1/2 is 1/2. 3 times 1/3 is 1. 1 times 1/3 is 1/3. 4 times 1/4 is 1. 1 times 1/4 is 1/4. 5 times 1/5 is 1. And 1 times 1/5 is 1/5. I notice that boom, 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 boom can all reduce. Cool there. Okay. So now I can use property 1 in the numerator to rewrite that as 3 to the 1/2 plus 1/3. And I can use property 4 in the denominator to subtract the 1/4 and subtract the 1/5. Is that okay, me doing that both at the same time? You could do it as 2 separate steps too. This is just a little bit faster. So then I will find a common denominator. The common denominator between 2, 3, 4, and 5 is 60. So I multiply the first by 30 over 30, then by 20 over 20, then by 15 over 15, and then 12 over 12, or 12 and 12. So that's going to give me 3 to the 30 over 60 plus 20 over 60 minus 15 over 60 minus 12 over 60. So 50 minus 27 is 23. And then that's the 60th root of 3 to the 23rd. And if you wanted to, you could type 3 to the 23rd into your calculator. You get some godforsaken big number. Let's see what I get when I do that. 941,431,78827. But you could leave it as 3 to the 23rd. I wouldn't be mad at that. Does that feel okay, Reese? So either of these would be okay. I actually don't know that your calculator would give you all those decimal places. I think it probably default and start giving you scientific notation. Since I used the Big Daddy over here to do that one. Cool. Anybody else? All right. Well, judging on the sparsity of homework 4 questions, my guess is that not a lot of us got all the way to that, which is fine. Again, it's not due until the day before we come back from break, so if you didn't start on it yet, that's no big deal. It is quite challenging, though, and maybe in hindsight, bitten off a little bit more than maybe we should have been chewing there to start. So if you hadn't started it yet, that's okay. what we should have probably done first is something like this, what I've set up here for homework 5. And this is what we're going to work on today in class. So you've already started homework 4. That's fantastic. You've done a good job and gotten ahead of stuff and have gotten some good exposure. But you're probably like, ugh, that's a lot of parts where you're like, am I done? I don't really know. Like, is there more to do? Blah, 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 blah. And that can be kind of challenging. So what I've done here on homework 5 is I've given you the start. That's in black. And I've given you the end. That part's in red. And I want you to kind of fill in the steps in between on how you get from the black to the red, which I think will be kind of helpful to have like the start and the end, and you're just kind of filling in some stuff in between. Does that make sense there? Okay. Just before we start doing that, though, let's kind of run through what we had done last time in class and do a couple of examples to just kind of refresh our memory, and then we'll release you guys to let you get started on stuff. Sound good? It'll be a pretty low-key, chill day, just working on some problems, trying to get a little bit better at this. So last time we gave a new definition for a radical, and that we can rewrite these radicals as fractional exponents. That's that very first definition there. And the advantage of that is that if we have things in exponential form, we have these 7 properties of exponents that we have access to, and allow us to manipulate things a little bit more cleanly than we can if we just have radicals, because we have a far less tools at our disposal to deal with the radical than we do as the exponential. So these were all in our notes from last time. So let's run through a couple of examples of kind of doing this. One of these simplifying problems. So again, I haven't given you the end here, but I'll kind of walk through what we do. So in general, my first step is going to be to do a prime factorization. I notice that 8, 4, and 32 are not prime numbers. So 8 is 2 to the 3rd. 4 is 2 squared. And 32 is 2 to the 5th. And then I'm going to convert. Let's not do it that way. It'll be a little bit cleaner maybe to just think about it this way. So there's that. Everybody good there? Now I'm going to use my definition to rewrite these as exponentials. Notice that I don't have an index written there on the square root, but we understand that a square root, the index is 2. The 2 is there, we just never write it. You can if you want to. I never do. So that becomes 2 to the 3 halves, and then 2 to the 2 thirds, and then 2 to the 5 fourths. Everybody's okay with that? Just using our definition to decode those. Now this looks like property 1 to me, where I have things with the same base being multiplied together. Right? So notice when I multiply these together, the base doesn't change. I just add the exponents. So here I'm going to have 2 to the 3 halves plus 2 thirds plus 5 fourths. I need to make a least common denominator there to add those fractions. In this case, that common denominator would be 12. So I'll multiply the first one by 6, and then 4, and then 3. Everybody's okay there? So I'm just going to kind of write it that way to, if you're going back to look at things. So 18 and 8 is 26, and then 15 is 41. I've got that down to a single piece, or I've combined all the like terms together that I can. So now it's time to convert this back into a radical. So the denominator of my fraction is the index. The numerator of my fraction is my exponent. But I have a little bit of a problem here, because I notice that my exponent is bigger than my index. That tells me that there's some reducing that can do. So I'm going to break up those 41 2's into packets of 12. So I can get 3 packets of 12, that's 36. And that leaves me 5 leftovers. So I have 1, 2, 3 2's that I can take out front. And then I still have that 5 2's left underneath. Everybody okay there? And then I can just multiply my stuff together. So 2 times 2 times 2 is 8. And 2 to the 5th is 32. Okay with that? I have one more example plan to kind of run through, and then we'll just get out of your way and let you guys try to work on stuff. Sound good? All right. So this one, I noticed that I don't have any radicals to start with, which is fine. No big deal. Just one less thing to do, I guess, right? So I'm going to start by doing a prime factorization, since I see none of the bases are the same and none of the exponents are the same. So there's no like easy combining that I can do in this problem. So 6 is just 2 times 3. 18 is 2 to the 3rd. I'm sorry, 8 is 2 to the 3rd. There's no teen. 12 is 2 squared times 3. Everybody okay with that? So these two places look like property 2 to me, where I have two things multiplied together inside a parenthesis with the exponent on the outside. So I'm going to use property 2 to simplify those. Basically, all I do is I apply the exponent to each piece of the product. So that's fine, easy to do there. So I have 2 to the 1st to the 2/3, and then 3 to the 1st to the 2/3. That other piece I'm not going to do anything with right this second. And the denominator, I have 2 squared to the 7/9, and 3 to the 1st to the 7/9. So far, so good. Okay. So each one of these, I have like an exponent on the inside and an exponent on the outside. That's property 3. And property 3 says we just multiply the exponents together to simplify them. That's easy enough. So 1 times 2/3 is 2/3. 1 times 2/3 is 2/3. 3 times -5/4 is -15/4. 2 times 7/9 is 14/9. And then 1 times 7/9 is just 7/9. So far, so good. Okay, so I notice now that these 2's, now that all the parentheses are cleared, can go together. So the ones that are being multiplied together in the numerator will add the exponents. the one that's being divided, the one in the denominator, will subtract its exponent. Sound good? So that's going to be 2 to the 2/3 plus negative 15/4 minus 14/9. And then similarly with the 3's, I have a 3 in the numerator and a 3 in the denominator, so I can combine those by subtracting their exponents. So 2/3 minus 7/9. So if I look at the 2's, I have 2/3 minus 15/4 minus 14/9. So the common denominator between 3, 4, and 9 is 36. So I need to multiply this first one by 12 over 12, and then 9 over 9, and then 4 over 4. For this one, the least common denominator is 9. So I need to multiply the first fraction by 3 over 3. And then the second fraction, I don't need to do any changes to. Landon.
So the first one, how do you find the least common?
Well, I have a 3, a 2 squared, and a 3 squared. So my least common denominator would just be 2 squared times 3 squared, which is 36. Or you could just do it by inspection. And if you don't get the least common denominator here, it's not a big deal. So if you find any common denominator, you'll be all right. You might have some reducing to do at the end, but since it's just a fraction, like it's not that big of a deal if you don't get the least. Is that okay?
Yeah.
Lily?
Why don't both of those have to share?
Because they're in different exponents. One is in the exponent of the 2 and the other is in the exponent for the 3. So we don't need them to have the same denominator because we're not going to ever add or subtract them together. Is that cool?
Yes.
Okay, good questions. Let's keep on going then. So that's going to be 2 to the 24 over 36 minus 135 over 36 minus 56 over 36 times 3 to the 6 over 9 minus 7 over 9. So 24 minus 35 minus 56 is negative 167 over 36, and 3 to the negative 1/9. We don't know okay to here. We got this negative exponents going on, but we had a property that describes what to do with those. So if I go back and I look at my properties, property 9 says if I have a negative exponent, it just makes the reciprocal of the positive. So that means I'm going to have 1 over 2 to the 167 over 36 times 3 to the 1 over 9. I've now combined all the like terms and I have positive exponents, so I'm now going to rewrite these as radicals. So using my definition, that's going to be the 36th root of 2 to the 160 to the 167, and the 9th root of 3 to the 1st. But my exponent is bigger than my index there. Let's see, 1, 2, 3, 4. So I can break that up into 4 packets of 36 and then a leftover 23. So that means that I can pull 4 2's out front, and I'm left with a 2 to the 23rd underneath. We okay there? Landon?
So, can you just explain how you're able to pull out 4 to 36?
So I did 167 minus 36, and I could do it 4 times when still getting a positive number. And then the 23 is what I got before it gave me a negative. So I just did 167 minus 36, and I just kept doing it until I couldn't do it anymore, basically. Is that okay?
Yeah.
So that's all I did in my calculator. It was pretty quick, right? Okay, but again, because I have radicals in my denominator still. Bugger. So if I look at the first radical to get rid of this 36th root, I need 36 2's. Right now I have 23 2's. How many more 2's do I need to get to 36? 13. So I'll multiply the top and bottom by 2 to the 13th. And then if I look at my 9th root, to get rid of a 9th root, I need 9 3's under. Right now I have 1 3. How many more 3's do I need? 8. So the top and bottom I'll multiply by 3 to the 8th. So 2 times 2 times 2 is 16. And then I have a 2 to the 36 and a 36th root of 2 to the 36, and then a 9th root of 3 to the 9th, and then all this stuff in the numerator. So 2 to the 36th, taking the 36th root of is just 2. 9th root of 3 to the 9th is just 9. So the denominator, I just have 16 times 2 times 3, or 96. In the numerator, I'll type 2 to the 13th in my calculator to get 8192. So I have the 36th root of 8192. And I'll type 3 to the 8th in my calculator. That's 6561. So that's the 9th root of 6561. And that's my answer. Landon.
Could we leave it in like 2 to the 13th and 3 to the 8th, or do we have to?
Yeah, that would be fine. You can leave it as exponential if you've got it all the way simplified. Yep. Now on the homework, homework 5, I'm going to leave it as, I'm going to multiply, I multiplied everything out. Mostly because it was easier to format clearly what the answer is going to look like without like exponents under radicals, and just like it got to be kind of busy looking. And that looked a little bit cleaner when I typed it out. But yeah, it would not be wrong. Again, if you prefer to leave it as that, that's still totally cool. Okie dokie. Okay. So I'm going to release you guys now. You guys can work on